So for our notes today, we are working on max-min word problems. Now, when you have a max-min word problem, there's two different ways you can solve it. One way is you can solve it graphically. Now, when you go to solve it graphically, you actually have to draw a picture of the graph. If we look down here, your graph needs to include a scale, labels, and any points to be used to answer the question. That's what needs to be on there. All this other stuff up here, that's for if you have to make your own scale. But you know what the nice thing is about the Regents exam? They always give you your scale, so you don't have to make your own, so we don't have to really go through that. The one part I do want to go through is vertex form. Y equals x minus h squared plus k. That's just another way that they can write your quadratic. Some people get confused by that because the squared is outside of the parenthesis, but you would still get an x squared term if you were to multiply everything out. So that's still a quadratic. It's just a different way of writing it. And of course, we still always have our regular standard form. So ax squared plus bx plus c. So let's take a look at our first problem we have down here. We have the height in feet of a golf ball hit into the air is given by h of t equals negative 16t squared plus 64t, where t is the number of seconds elapsed since the ball was hit. So again, these first parts, that's if you have to create your own scale, but they give us our own scale, so we don't need to do that first and second part. We need to create a table of values so that we can graph this. So in your calculator under y equals, I want you to type in your negative 16t squared plus 64t. In your calculator, you can't type a t, so you're going to type in an x instead. So we're going to do negative 16x squared plus 64x. If you do notice, though, on that button we use for x, they have a t on there to show you that that's what you would push to get your t, but they can't actually do a t. So if we look at our graph, we really can't see too much of it, can we? No. You just get a couple of lines on there. So let's look at our table. Now for our table, what we're going to copy down is we're going to copy down from where x is 0 to where x is 4. Because with our time, we can't have a negative time, so that's why we can only start at 0. And I want to stop at 4 because that's when my y reaches a 0 once again. So copy that down from 0 to 4. So we got 0, 0, 148, 264. 348 and 40. So once you have your table, go ahead, plot your points. We always have to remember to label our graph when we draw it. So if we take our look at our list up here again, it says the graph needs to include a scale, which ours already had the scale on it. Your x and your y axes already had your scale there. We need to include labels, so that's what we're missing. We've got to label our x and our y axes. With these problems, 99% of your time, your x-axis is always going to deal with time. Our time in this problem is seconds. So down here we would label our x-axis as time in seconds. And And then what's the other thing we're talking about in this problem? Height in what? In feet. So that's what we're going to label our y-axis as. So you always got to label your x and your y. And then the last thing was to use any points to answer the questions. All right, so we already got those points because we got our table of values here. Now these graphs aren't going to have arrows continuing on, because if you think about it, if I had an arrow telling me I was going to continue going downwards, I'm going into a negative height. My golf ball can't have a negative height. It's either at the ground, which is 0, or it's going to be up in the air. So now you can either use your little table you've drawn, or you can look at the graph that you've drawn over there to answer your questions. What is the maximum height of our golf ball? 64 what? Feet. Here's where our maximum would be. So if we look over to height, it was 64 feet. How long does it take for the ball to reach the maximum height? 2 seconds. Good. Again, if I look at my maximum, I look down at my time. It took us 2 seconds to get there. Bless you. How long does it take for the golf ball to hit the ground? Yep, because it starts over here. This is when it's hit, and it goes up, and it's in the air, and it comes back down at 4 seconds. For how many seconds is the ball more than 48 feet up in the air? So here's my 48 feet. So it reaches 48 at 1 second, but then it's up here. Here's 2. Stops at 3 seconds. So how many seconds went by? 2. So it starts here. It's above 48 for 1, 2 seconds. And then the last one, determine all values of t for which the height, h, is greater than 48. So we just said it was from 1 second to 3 seconds. So the way we write that is a little inequality. 1 is less than t, which is less than 3. If you can't remember how to write that, then you can still write 1, 2, 3 seconds. You would at least get some credit for writing that. And it shows that you know what you're doing. So that's if they ask you to solve it graphically. Personally, graphically is my favorite way to solve it. I think it makes it a little bit easier. If we take a look at the back, sometimes they do ask us to solve it algebraically. So we have a model rocket is fired upward from the ground with initial velocity of 88 feet per second. Its height in feet above the ground as a function of time in seconds is given by this equation here. They want to know, when does the rocket reach its maximum height? What is the maximum height of the rocket? And when will the rocket hit the ground back down again? So I have this little box over here on the right. Because instead of using x and y, they use h and t. So some people, they want to put it back in terms of x and y. Some people, it kind of confuses them when they do that. So really, it's up to you. You can use x and y, you can use h and t. What the main thing is that you have to keep in mind is y. That's dealing with your height. Remember, the y is your up and down. X is dealing with your time. As I said, the majority of these problems always have a time. That's always your x. So if they ask us, when does the rocket reach the maximum height, they're asking us a time question. So which letter should we be looking for? X. But instead of x this time, they're using what letter? T. So we would normally use x equals negative b over 2a to find when does it reach its maximum. That's our axis of symmetry, like what we were doing on our problem today. But instead of using x, they're just using the letter t. So you just got to switch that. So in our equation over there, what is our B value? Our B is an 88. So I have to put a negative in front of it. So negative 88 over. What's our A value? Negative 16. So it's 2 times negative 16. So if I multiply those in my denominator, I get negative 88 over negative 32. So let's have you divide that out. I believe we get a decimal. So when does the rocket reach its maximum height? It reaches it at 2.75 seconds. So then our next question is, what is the maximum height? So what should we do with our 2.75?
Plug in for every t.
Yep, plug it in. So we're going to plug in 2.75. Negative 16 times 2.75 squared plus 88 times 2.75. And then you can type that in the calculator just like that with all the parentheses and everything. Negative 16 times 2.75 squared. Anybody get an answer yet? $121 feet. So the maximum height of our rocket was 121 feet. You gotta be careful, those negatives make a big deal. Alright, so then part C, when will the rocket hit the ground? So let's think for a second. The graph of this equation is going to look very similar to the graph of the equation we did on the front. It's going to be one of our upside down parabolas because our A value was negative. We had a negative 16 in the beginning, so we knew it was going to be upside down. We're looking for when it hits the ground, which would be right there. The ground level being our x-axis. So we know so far when it reaches its maximum height, which is where in the parabola? It's in the what? Middle. So what do you think I could do with that number to get me to the ground? If this is the middle, I want to go over here to the ground. We just got to double it. So it took 2.5 seconds, 75 seconds to get to the middle. Multiply it times 2. How long is it going to take for us to get to the ground? 5.5 seconds. That's the other nice thing about your axis symmetry. It's always in the middle, so if you just double it, that's where you're going to find when it hits the ground again. So in our last question here, it says future projection for sales of a company are modeled by the equation given, where S represents sales in thousands of dollars and X represents months in the future. Over the next year, what is the minimum amount of sales expected for this model, and in how many months will this minimum amount occur? So we got 2 questions to answer here. What is the minimum, and in how many months will it occur? We can't find the minimum, though, until we know in how many months is that going to occur, because we have to find our X value first. So X equals negative B over 2A. You always got to figure out the time, and then you can figure out the other number after that. So looking at our equation, what is our B value? Negative 24. plus we have the negative from the formula, so we have a negative negative 24 over 2 times, what's our A value? 2. So what happens with our negative negative 24? Positive. So I have 24 over 2 times 2 gives us a 4. So what is 24 divided by 4? 6. So in 6 months, that's when we'll reach our minimum. So we answered the second question first, but that's okay. You always got to get the time before you can get the other number. So now what do we do with our 6? Plug it back into the equation. That'll tell us what the minimum amount is. So 2 times 6 squared minus 24 times 6 plus 100. What do we get? Come on, you should all be typing it in your calculator. You got to practice. 28. But that's not our final answer. 'Cause remember, it said that sales were in thousands of dollars. So it's really 28 what? Yep. It's 28,000 will be the minimum. There we go.